Hey scholars, so today we're going to be getting back to 2009 for the AP Calculus BC free response questions, and we're going to be doing number 4, which involves differential equations, Euler's method, separation of variables, and Taylor polynomials. So we're going to start with A, and I'm just going to refresh you on what the Euler's method is. So it's a way of estimating how something's going to perform on a graph. So you look at the so for example, you have a starting value, say right here, and you figure out the slope at this point and continue up a certain amount, and then you get to this new point and you find the slope at that point and you continue up, and if it's modeling, say, something that looks like this, then it's going to be reasonably accurate, and so Euler's method carries some validity. And actually, if you do an infinitely fine Euler's method, then it's just going to become the graph itself. So let's get started with A. So we want two steps of equal size starting at x equals minus 1. So we can tell that f of minus 1 is equal to 2. So it's going to be 2 plus, 2 plus f prime of minus 1, which in this case is going to be, we get 6 times minus 1 squared, because we're looking at x equaling minus 1, minus negative 1 squared again, times 2, and I put 0.5 here because the Euler steps are both going to be 1/2. So this is going to get us from negative 1 to 0.5, negative 0.5 right here. So we're going to be essentially moving like that. So it's going to be 2 plus 2, because this becomes 6 minus 2 times 0.5, which is 2. And so now we have 2 plus 2 plus, and now we get 2 minus 0.5, so 6 times minus 0.5 squared minus negative 0.5 squared times 4, and then all of that times 0.5. And so that's going to compute out 6 over 4 minus 4 over 4 times 0.5, which is, that all computes out to 1/4. So it becomes 2 plus 2 plus 1/4, which equals 4 1/4 as the approximation for f of 0. Alright, so let's move on to B. Okay, so for B, at the point negative 1 comma 2, the value of d squared y dx squared is negative 12. We want to find the second degree Taylor polynomial for f about x equals minus 1. And so just a reminder about Taylor polynomials, those are also ways of finding estimations. So for these, they are polynomials generally involving like x squared, that sort of thing. And they are a way of making things that are just ugly a little bit prettier. So for this, what we're going to want to do is look at what is a Taylor polynomial, and the way you do it is f of x minus a plus f prime of x minus a. Rather, it's f of a plus f prime of a over 1 factorial times x minus a, and plus f prime prime a over 2 factorial times x minus a. And so in this case, what that's going to look like is, this is, now we know that f of a at x equals minus 1 is going to be 2, so we can put that in 2 plus f prime of a. And so f prime of negative 1, if we computed that out here, the f prime of negative 1 is 2. So 2 plus 2x minus negative 1, so plus f prime prime of a, which we can see is negative 12, so that's going to be negative 12 over 2 factorial x minus negative 1. And so there we're going to now have the Taylor polynomial for f about x equals negative 1. Alright, so let's move on to c, which I think in this problem is the kicker. So we want to find the particular solution y equals f of x to the given differential equation with initial condition f of minus 1 equals 2. So to me this just absolutely screams of separation of variables. That's not nice. So one note seems to have failed majestically, but I'll just keep going. We want to take a look at the differential equation right here. So if it'll let me write, technical difficulty.
It's moving very slowly.
So dy, if it'll let me write, dx, come on. Okay. Alright, so it seems to be mostly better now. So what we want to do is we want to use separation of variables in order to find the solution for this problem. Now we want to just to rewrite this so it fits our liking a little bit more, it's going to be x squared times 6 minus y equals dy dx. And now to separate variables, 1 over 6 minus y dy equals x squared dx. And now the next step is to integrate on both sides. And what we're going to get there is x cubed over 3 plus c equals minus
ancient airs and dances
equals minus ln of 6 minus y
This is the kinds of growth.
plus c. Alright, so from there, great, beautiful. So let's just move this minus to this side, and it doesn't matter about the c, it can be plus or minus, no question for us. And let's raise everything, use everything as a power of e. That makes this just 6 minus y equals k e to the minus x over 3 cubed. So the next step is let's just plug in y and x. So when x is minus 1, y is going to be 2. So 4 equals k e to the minus 1 cubed, so that would be 1/3. So k is going to be 4 over e to the 1/3 equals k. So now if we just want to really put this out there explicitly, then it's going to be 6 minus y equals 4 over e to the 1/3 times e to the minus x cubed over 3. And come on, OneNote. Come on, OneNote. So we can do minus 6 minus, and then this goes away. And so that's going to be our answer. And I'll just clean this up to make it. So it's going to look like this here. So yeah, I hope this has been helpful in learning how to work through this problem. I've had some technical difficulties, but yeah, I hope you feel like you've learned a lot. Thanks a lot.